talk about just one specific topic here, the concept of closures and how we could use closures with quite a bit of productive things we could do with it. Let's talk a little bit about what are closures. I'm taking a fairly narrow concept here, but it turns out that Groovy does enormously number of things with closures in Groovy, so we'll talk about quite a few things we could do with it. Let's talk a little bit about what's closures, and then we'll talk about how do we create them and use them, and some of the concepts that Groovy offers in terms of the power that this offers. One of the first questions I would ask myself is, several languages are supporting closures, and Java 8 is going to support closures as well. Well, does it mean that what we're going to see here is something we could use in other languages, and especially in Java? And the answer is twofold. Maybe about 50% of what we will talk about here you can use in Java, but there are quite a few other things we're going to see here that pretty much is specific to Groovy, and I don't think we'll be able to use that in Java, for example. And some of those are related to the ability of Groovy to mix closures, but also with specific ways in which Groovy handles things, and also how Groovy metaprogramming kind of kicks in, and obviously Java doesn't have metaprogramming anywhere to the extent that Groovy does. So there's a few things we'll see which is Groovy specific, but things that are other things that we could use in other languages as well. But what's a closure, first of all? Let's talk about that. Simply put, you can think of a closure as anonymous method. Now, if you want to get very technical about it, if you go talk to somebody who is pedantic, and they would get angry at you if you say you're using a closure, and they would say, that's not a closure, that's a lambda expression. My recommendation is stay away from those people, right? Because there's no point in getting that argument. You just say you're right and then just move on. And yes, there is differences, but Groovy, programmers simply don't care. They just want to get their work done. They don't want to sit there and define things so tightly. We'll talk about what the difference is. It's a good thing to know the difference, but we will kind of loosely use the word closure most of the time for lambda expressions as much as closures. And that really makes life a bit easy, because then we are spending our effort in using it rather than sitting there and thinking about the definition more than so. So what is it really? You really are talking about an anonymous method. Now, let's think about this for a second. What do we do in Java when we want to send invoke a method, but we want to really send implementation? We are forced to hide behind a class implementation. So we would implement interface or a class. And back in time, Java 1.1 introduced the anonymous inner classes. That was an opportune moment, so to say, that was missed. Because rather than introducing anonymous inner classes, they should have gone full force and implemented lambda expressions. They didn't. Now they're trying to do this in Java 8, of course. But Groovy already has it. It has it from day one. So for example, I could simply write a little thing, a method called greet, and the greet method takes, let's say, a name, for example. And then, of course, I could print out, and here I could say hello, and then I could print out the name. We just wrote a method. You could write this in Scala, you could write this in Java, you could write this in Groovy, and I'm going to call this greet method, and then here, of course, I could say, greet and pass the name to it, right? So this is a function we wrote, a method we wrote. But rather than creating a method like this, I'm going to turn this around just a little bit. So I'm going to turn this into a simple variable with the equals. And this time, I'm just moving this curly bracket to the beginning instead of this place. And then we'll just turn this around into a little indicator. Now, what are we doing in this case? Just I turned around a function into a closure. That's all I did, right? Didn't change a whole lot. And now it's a semantic difference more than anything else. Rather than defining a function, we defined an anonymous function. Of course, we assigned this function to this other function, in this case, this variable called greet, but we have a function that's floating around now, and then we called it. Now, calling this doesn't seem any different from the way that we called a function a few minutes ago, but it's a closure we are dealing with. What's really happening under the covers? When you're calling a function, of course, you're doing an invoke on the function. But what really happened here is that it's calling a special function called call. So if you notice, these two guys produce the same result. In fact, line number 5 is a syntactic sugar. Line number 5 is actually compiled into line number 6. because you are calling this. So this kind of gives us a clue what's going on. A closure is really an object, and we are calling a method on this object at this time. And this object is a reference to this object is held with this variable called greet. And line number 6 probably is a little bit more comfortable for us, right? Because if greet is a reference to an object, you're calling a call method on it. That makes sense to us, right? So that's what you're doing under the covers, is that you're calling this call method on this object. But in Groovy, you don't have to go through that length, and you can remove that dot call and simply call this using the notation you see on line number 5. So it's an anonymous method. Now, what can an anonymous method take? An anonymous method can take any number of parameters. So I could say name1, comma name2 over here. And of course, I can print name1 and name2 if I wanted to. So in this case, I could call greet, and I could call 2 different names, right? I could send, Joe and Scott over here. And of course, I kind of decided a little bit to break away from convention. Because when Scott is involved, it's hard to follow convention. I mean, here's a man with the long hair. So as a result, I can say, parentheses is really not required, right? I can kind of move away from convention. And now I can just say greet, and then Joe and Scott. And I can give multiple values in this case. So you can see that parentheses becomes optional. But this kind of takes us more towards a lightweight syntax, more of a DSL, and then we can start using some of those things. So you can see how you can pass multiple parameters. So it behaves a lot like functions, but except that it's a function, but it's an anonymous function. So that's what a closure is. But let's talk a little bit about, underlying difference if you want to. Let's spend a minute on this. So if you look at this for a second, what does greet have? Greet has a name, let's say name. And so I pass a name to greet, and then of course I'm going to print it. Now if you stare at this for a minute, you can ask what this name is. And it's fairly clear what that name is. That name is the parameter coming into this anonymous function. So that's very clear. So in that context, you may want to call this as a lambda expression. So a lambda expression is an anonymous method where all the variables it is using are fairly well bounded. And that's basically what makes this a lambda expression. But I'm going to change this just a little bit. I'm going to turn this around, and I'm going to say $message, comma name. Now you can ask the question, what is name? Why, that's exactly the same as the name you had a minute ago. That's a parameter. But then you say, what is MSG? Well, I don't know what that is. In the context of the function we have defined, we don't know what it is. So we have 2 variables within this expression. One is the name variable, and we know clearly where it's bound to, which is the name. But what about MSD? That is unbounded. Now, of course, you cannot call this closure, right? Because if you call this closure, it's going to error. It's going to complain that it doesn't know what MSD is because we haven't defined it. So in other words, you cannot call this closure. So for example, I cannot call greet, and I cannot just say Joe here, because if I run this, it's going to fail because it doesn't know what MSD is. So this expression is broken, isn't it? But we're going to change this a little bit. We're going to go back over here and say MSD equals hello. And now I go run the code, and notice it works. How did it do that? Well, if you look at this context now, this particular closure, this particular lambda expression says, I've got name, and the name is bound to my parameter. But MSD is unbounded, so I'm going to go look for it. Where is it? So it looks for the variable in its own scope. It doesn't find it. So now it goes into the scope of its own definition. In other words, it goes to its parent definition scope and says, hey, wherever I am defined, is there a variable called MSD? And it says, yeah, there is the variable called MSD. I'm going to grab it. I'm going to bind to it. So it binds to the variable in the defining context. Now, let's think about this for a second to understand how this is going to be a little different. Now, I'm not going to call greet over here. I'm going to define a function, foo, and to this function, I'm going to pass a closure. And within this function, by the way, I'm going to define MSD equals by. And now I'm going to call greet, and I'm going to send Joe over here to the greet function. And now I call this is going to be the closure, right? Closure. And in fact, let's even do that. Why even bother it? We can even call greet from here. So let's call greet right here. So I'm going to call foo, and I don't need to pass closure to it. Let's watch this for a second. Now, in line number 11, I call foo, and the foo gets into line number 6. Line number 7, I define MSG, and then I call greet. And greet calls into line number 2, and then it's going to print. Now there is MSG. What is going to be the output? Is it going to be hi Joe, hello Joe, or bye Joe? You're ready to get rid of him, right? Bye Joe. By the way, it doesn't matter which answer you gave. It's both of them are right. Not at the same time, though, hopefully. Right? Sometimes I do this to Scott. Hi, Scott. Bye, Scott. Right? I don't want to talk to him anymore after he harasses me for a few minutes. But the point is, which of those is right? Now, let's step back for a second. Which of those would make the program easier to understand? Depends on which language you program in. One is called lexical scoping. In other words, if I okay, let's think about this for a minute. What if I write another function here, define f1, and here I define message again equals to something, right? Then I have defined another function f2. Within that I define msg again with some other value. Then I call greet over here. Now I ask you which of those, which is going to be easy to understand? Binding to this MSG or binding to the one that you define in this context over here? Right? So if you're binding to a definition in your own calling context, in your defining context, that is called lexical binding. Lexical binding is you are looking at your lexical order. In other words, where are you being defined? That's lexicality, right? Like in a dictionary, it's a lexical order. That's called lexical scoping. If you are binding to where is the closest at runtime, that is called dynamic binding. Dynamic binding means at runtime, you look around and say, I'm going to use that one because that's the nearest definition. Now, from the program readability point of view, which is easier? Lexical scoping or dynamic scoping? Lexical is easy, right? Now you know why. I'll give you a quiz. What do you think Perl uses? It has to be dynamic because we said easy, right? Easy and Perl don't go together, right? So now you know what Perl uses. Perl uses dynamic binding. Whereas Groovy, in most of the languages, JavaScript, for example, Java, for example, when Java 8 comes out, most of them use lexical scoping. So in this case, if we go back to this code, where we wrote the function foo in this case, and we are calling this function foo, run this, actually in this case I'm calling the greet method. Let's resolve the problem here. It's got to know what this greet is, so it's probably complaining that it doesn't know what that particular greet method is. Let's see if that's a problem he's giving. So what method is complaining? Yeah. So let's say I have this in the global scope for him for a minute, right? So we're telling him to go get the value. You can see hello Joe, even though we defined MSD as bye. So what's going on in this case? This lambda expression says, I've got this message unbounded, and I cannot function without this message. So I'm going to go look for it in my defining context. In other words, this lambda expression cannot function unless it closes over the scope of its definition. So in other words, this lambda expression is going to close over. Now say the word close over many times really, really fast. And with a bad accent, it becomes closure, right? So that's, now you know where the word closure came from. Closure closes over. So it's really a short form of closing over. So a lambda expression with unbounded variables closing over the scope of its defining scope becomes a closure. If a lambda expression doesn't have any of these unbounded variables, then it's just a lambda expression. But we don't care. In Groovy, we don't make this distinction. It's good to know this because you're going to always have this guy. Let's say you're on a very long train ride, and the guy next to you says, what are you doing? I'm using a closure, and he gets into an argument. You can't jump off the train, so it's important to have this definition. Say, I know the definition, now you be quiet, and I'm going to go program in closures, right? So the point really is, it's good to know the distinction, not from being pedantic about it, but to know what's going on here, because lexical scoping is something we need to understand. because lexical scoping tells us how the scoping gets resolved, and that is something for us to know. All right, how do we create a closure? Well, we already did. We created a variable in this context, and then we said, I'm going to simply call that closure, and then send values, whatever that we want to send over here. So in this case, let's say Joe, and we can send this particular object, the closure value, and we are able to call it. So how do we use closures? We can use closure by calling methods like this, but where it gets a lot more interesting is when you can pass closures to other functions. So for example, I can write a function here called greet, but the greet function itself can take a closure and a name as a parameter. We could do this. And then we could say what kind of result this closure is going to give. So we could say something like message equals closure. We could call this closure to get the message. And then, of course, once we call this, we can say print with the message and the name itself, right? We could say message and name. So to call this, of course, we're going to call greet. But it has to take two parameters. The first parameter is going to be the message it's going to produce. And the second is going to be the name that we're going to use to print this. Now, in this case, of course, notice what we did. We passed the closure as the first parameter, and the second parameter is just an object. Now, this is how you can pass closures to functions. You can have as many closures as parameters to functions if you want to. But on the other hand, if we change this a little bit, and let's take this closure, but we don't have to call it closure, we can call it whatever we want to do, and let's move this to the second parameter. Now what happens? We can say Joe here, and then we could write it like this. So we're just swapping these two parameters, right? So what's the big deal? What's the big difference? Well, the difference is, if you have this situation, you could do a little bit of minimization. Rather than putting a comma here, and then closing this here, you can simply move this up here, and get rid of the comma. So you're reducing the noise just a little bit. And notice both of them produce the same result. But how can I do this? This one is special because, did you notice in the previous example, the closure was the first parameter. In this example, the closure is the last parameter. What's the big deal? Well, the last one is special. Kind of like last child in the family, right? I know it because I was not one of them. Right? And the last one are being treated specially, isn't it, Scott? I know it. Right? So that's basically the issue here, is that if it's last, it's special. And what do these last things do? They can hang on to the parents like they're parasites. Right? So notice how I was able to hook it up over here, and notice how we're able to close the call and then move it outside and hang off of it, right? So that is a very lightweight syntax, but most of the time when you're writing Groovy, that's the syntax you're going to use. You rarely actually pass it within comma-separated values because this is a lot more lightweight. So we call this the idiomatic way of writing things. Idiom, what is an idiom, by the way? Idioms are a way of saying something, a usage form. Now, we could learn somebody's language, right? I mean, you could say, I speak English. Well, we can speak English, but when you go to England, for example, they would say certain things and you would like, what does that mean, by the way? And you would say, okay, I took these combination of words, and then you look in the dictionary, and you don't have a clue what that means. Or then you go to another country where they speak English, and they say something, it's like, what does that mean, by the way? And you don't understand what that means, because idioms are often formed through a cultural connotation and a usage pattern. And the only way to know the idiom is to mingle with that group of people, which applies really well to languages, by the way, because a great way to learn a language's idiom is to pair up and mingle with the people who program in the language. Then you pick up the idioms. So while you could write code like in 6, line number 6, if you do that, people will say, you're new to Groovy, aren't you? You're not writing an idiomatic code, and then quickly you would go towards the one in line number 8. So we really are calling this function in this case, and we are using the closure. Now, there's something else that gets very interesting when it comes to closures. Let's get back to this example for a minute. Notice in this example, I have a greet method, and I mentioned that I could simply say message and name over here. And maybe what I would like to do is I'm going to simply replace this. So I'm going to call greet, and I'm going to say Joe here, but I'm going to then go back here and say to uppercase, and then I'm going to call it this way. Let's put that as an expression for a second. So this gets a little bit more interesting, isn't it? Notice what I did. I said greet Joe, but if you look at the greet method, I just called name. And earlier I said I'm passing a variable, and message was not defined, and you would go grab the message from the outside. Now it's a little different. I'm calling it to uppercase. Well, we know what to uppercase does. It converts things to uppercase. But what is it going to convert to uppercase? That is not clear. We can kind of scratch our head and say, what's going to happen? Well, if I run this code right now, if you notice, this code is going to fail. And it fails with the error, to uppercase is not a function, no such method. So obviously it failed. But why am I even getting to that kind of an, behavior? Because Groovy closures have a special property. And that is, the code you execute within a closure primarily runs in the context of a closure. But on the other hand, if a closure doesn't know what you're talking about, it doesn't yell and scream at you, it immediately turns around and looks at another object called a delegate object. For example, let's say Scott is my delegate. And you come to me and say, hey, can you do this? If I know how to do it, I would immediately serve you. And I say, here's how I'm going to do it. But if you ask me something I don't know about, I wouldn't tell you that I don't know. Instead, I would quietly forward it to Scott, my delegate, and say, hey, Scott, can you handle this? And Scott says, I can bang up some code right now and get it done, and immediately can solve it, and I will immediately deliver that result to you. So I used my delegate. This is an extremely powerful concept, by the way, because an object can receive the request, and I can attach delegates and do some really interesting stuff. Let's look at an example of how this flexibility helps. Notice what I'm going to do now. I go up to this code here and say greet.delegate equals, and I'm going to say here, hello. And then I run this, same code as I had a minute ago, right? I'm going to just run this code. So we set a delegate on this guy. Let me make sure I do this right. So greet is, forgot that I'm writing this as a function, isn't it? It should be a closure, of course. There we go. So run this. Notice what happened now. It said, hello, Joe. But then if I say greet.delegate equals, let's say howdy, and then I say greet Joe again, but this time notice it says howdy Joe. So what's going on? It's exactly the same closure, right? We didn't change the closure. We created the closure only once. But the first time, I pointed the closure's delegate to hello and invoked the closure. The second time, I pointed the delegate to another object howdy and invoked it. And this time it's using it. Have you seen anything like this in other languages? Anybody? This sounds very familiar to something else in an obscure language that seems very pervasive now. Most people don't have a clue how to use it, and yet Scott says this is a great language to use the entire stack of the web. JavaScript. What concept in JavaScript is this? That's correct, the prototypal inheritance. So Groovy closures really implement the prototypal inheritance. And of course in JavaScript, prototypal inheritance goes through multiple levels of prototype, which is possible here in Groovy also if the delegate itself is another closure. And then you can pass it down through delegates. So potentially you can implement a prototypal inheritance using closures. So it's a very powerful concept. So you can throw this around to do quite a few interesting things. Like, for example, to implement mocking and stuff like that, and fairly very flexible code you can do with this. Okay, all right, so far so good. Let's see how we can put these together to do some really fancy things. Let's say for a minute that you are developing an application where you want to send out some emails. Let's say this is Java code for a second. So I have a class called mailer. Well, maybe even you can put a word public if you want to make it more comfortable, right? So I have a mailer class. And how does this mailer look like? I'll say public void to, and I'm going to say address where I want to send the email to. And what would this say? I would say system.out.println, and I could say to, and say where I am sending it to. I could write it like this, right? This is just a note to let us know that this function is being called. Then I have a from method over here. And what does a from do? From takes an address. And in this case, it tells me that it's from. So I could print out from here, right? And similarly, I could say subject. I could say, body of the message. And then sending, for example. So all these methods, this of course is going to take a body, which is a string. So we could say message. And this could be just sending. I don't need a parameter for this. And this could be, of course, a subject. We'll call it the subject. And this method, of course, is going to be subject, right? Subject. And then this is going to be the body method. And then finally, the send method. So we've created a little class for sending emails. How would you use this in Java, by the way? Mailer equals new mailer, right? You would write it like this. And then mailer dot to. And you could say what you want to send. I want to send an email. To whom? Let's send it to Venkat. So who is sending this email? So from my build machine is going to send me this email maybe, right? So my builder sends this email, builder. And what is my builder going to say? It's got an important message for me. So it says subject. And the subject says, Venkat, your code sucks, right? So it sends me an important message. Continuous delivery is going to send this message, right? Continuous integration is going to send it. A mailer dot body, very important message. Let me tell you how, right? And it explains to me how my code sucks today. Because every day it's different, right? That's called refactoring, right? Okay. And the mailer dot send, finally, to call it. So that looks very familiar code, right? Anybody has written code like this before? No? Yeah, he's just doing this, right? It's okay, be brave. We won't tell anybody, right? We all have written code like this in Java, right? Absolutely, we have done that. Are we proud about it? No. I mean, the fact that you don't raise the hand shows it, right? You did it, but you were young, you needed the money. So you had to write it, right? If you lived in a free world, you wouldn't be writing it, right? Yeah, I understand. What's wrong with this code, though? Well, there are several things wrong with this code. Several things wrong. The first thing that's wrong in this code is it's noisy, right? Notice it said mailer dot, mailer dot, mailer dot, mailer dot. Would you tolerate this if the guy next to you keeps saying this every few minutes? Scott, Scott, Scott. He's going to strangle me, right? Why don't you just shut up? Tell me what you want. Don't keep saying Scott, 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 right? So it's noisy, right? It's very chatty. First problem. Second problem. You come to line number 15, the very last line. You say send. All right, done. Now you got this mailer object on your hand. Interesting. What do I do with this now? Can I reuse it? Can I change the to? And now can I tell how Scott's code sucks? And send him an email maybe? Can I reuse it? And we know the famous words for this, right? Go read the documentation. So we go to read the documentation. And what does the send method say? The documentation say, this method allows you to send. Excellent. Thank you for clarifying it. But dude, can I reuse this object? Now you won't tell. Now you're like, is it open source? Why? Now I can start reading that source code. And this is called hope. Because you're hoping that you actually understand that code. Right? So we don't know if we can reuse this object or not. That's not clear. And then one of your colleagues says, try it. It's like, sure. Now it seems to work until it doesn't. So we're not clear how to use this, right? That's one problem. So it's very noisy. We don't know whether we can reuse this or not. We don't know whether we should dispose it or reuse it, or should we go back and create another object. We don't know any of that. Let's see if we can solve some of these problems. Even in Java, we can solve this problem, right? We can solve this problem by making a small adjustment. We can go back to this code, and we will break away from the convention. And we will say, I'm going to return mailer from each of these methods. And in each of these methods, though, we will return, at the very end, we'll return the current object itself from each of these methods. Right? So each of these methods are returning the current object. Let's make sure the code is still working. We didn't change the body yet. But we can then now go back to this code, and we can quietly remove these semicolons from the end. And then we can come back to this code and remove this mailer from here. We could remove all this noisy calls, and then we can say, we can then run through. So even in Java, we can do this. By the way, There is a name for it. Some people will call it a cascade method pattern. But favoritely, you can also call it a train wreck pattern, right? Because it's like a train compartment arranged, and of course one blows up, everything fails after it, right? So a cascade method pattern or a train wreck pattern. You could do this in Java also. What problem did this solve? It solved the problem of the noise. You probably have seen this already, right? You probably have seen this in Juice if you use Juice. You have seen this in EasyMark if you used EasyMark. You probably used it in other tools as well. And sometimes people look at this and say, oh, this looks like a builder pattern. Well, it could, but there's several different intents for it. So we solved the noise problem. But what about the object problem? Did we solve it? Not quite, right? Because you could still create this object in the main. You can save away in the line number 1. And then you can start calling all that in that mailer object. Now you still have this mailer object on your hand. You're like, hey, what do I do with this object? Go read the documentation, right? The cycle repeats. So what's an answer? Well, let's not do this way. Let's turn around. Now we are going into the Groovy territory rather than the Java territory. So let's go back and remove these returns that we put, and let's make these void as we did before. So we're back to the noisy code. Now I'm going to go back and say, let's change this send method into a static method. So send became a static method instead of being an instance method. So we're not going to call the send method on an instance anymore because it's static, right? It's on the class. And then what we're going to do here is in this send method, we're going to accept a closure, a body of code. Maybe I don't want to call it body here because I'll call the other method body. We'll say a block. How about that? A block of code. I'm going to send him a block of code. But within the send method, now we're going to do this a little differently. I'm going to say mailer equals new mailer. So we created an instance of a mailer right here. And then in this method, now we are in Groovy territory, right? So we can remove all this junk about system.out. We can minimize the code, make it lightweight. And now I said create a mailer. And then I can call the block of code and send the mailer to it. Right? We kind of nicely sent this mailer to this guy and said, go, use this. When you come back, I'll call the send, I'll finish the processing. So notice the mailer has a to, from, subject, and body, but doesn't have a send method. It's a static method now. How would I use this? So now I will go back over here, and I would say, rather than calling these objects, we'll remove all of this. Well, actually, I need that for a minute, sorry. So I'll keep that in for a minute. We'll remove these semicolons. We don't need that. We can then say mailer.send. And now notice the mailer is taking a body, a block of code. So we'll put a closure. And we'll move this code inside this closure. We don't need the send anymore. We call the send up there. And we'll change this to mailer over here. So if you run this code now, it still works. But we turned it around. So what did we do in this case? We, rather than using the cascade method pattern, we said mailer.send, and we are passing it a closure block. And the send says, you call me, I will call your closure, but I'll create a mailer object and call it. And notice that within the send method, we created a mailer, and then we called the block, right? And the block says, you gave me an object on my hand, I'm going to use it. Remember, we had two problems with this, right? What were the two problems? The code was noisy, and we didn't know what to do with this object when we were done. Did we solve any of those two problems? We solved one of them, right? Which is, you know exactly what the boundaries of this object is, right? So you came in here, and you said, here's the mailer, and you finished this function. At the very end of the function, line number 19, you're done. You step over to line number 20, you say, what do I do with this mailer? What mailer? I don't have one. That context, the scope is over, right? The scope of the object started in line 14, and that scope ends on line 19. You don't have object. You don't have access to that object on your hand. And I can't reuse it. It's very clear. It's self-documented. You don't have to go read a documentation in this case, right? Because you get in, use it, and you're done. But unfortunately, it didn't solve the noise problem yet. You're still saying mailer, 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 right? So how do we solve the noise problem? Well, let's give this a try. I'm going to go back here, and I'm going to remove this mailer from here, because I don't want to keep saying mailer every time. I'm going to go back here and remove this mailer. So I removed all of that. In fact, while we are at it, we could even minimize the little, clumsiness here. Let's put a little single quote. And of course, I can remove this parentheses up here. I can turn that into a single quote, right? So we can get rid of those guys. So we minimized a lot of that. So we eliminated all that noise. Unfortunately, though, it doesn't work. Why? Because it's complaining when you come into the send. It says, to. What are you talking about? Yeah. That's the way I feel about it, right? Scratch your head. This is called scratching the head pattern. And usually when you scratch the head, you get the result, don't you? So what is it? How can you solve the problem? Using a delegate. You're right. What if we can run this closure in the context of the mailer, right? So now we are applying what we learned a few minutes ago, right? So after the little head scratching, we say, aha, I don't want to pass the mailer to this object. Instead, I say block.delegate equals mailer, and then we'll call this method. So notice how we introduced a context of execution in this code, right? Now, before we go further, we gotta fix this a little bit more. But before we go further, let's look at what we just did. What we did here is we call the mailer, and then the mailer, we stick the mailer as a delegate into the block. Then we call the block, and then when we call this method, it simply comes down here, and all this code runs in this context. Now, if you were in Neil's DSL talk, you slowly see how this code evolves towards a DSL, a lightweight domain-specific language. If you recognize the syntax, you probably see this already in other things you use. Grails uses this quite a bit. Within Grails, a lot of configuration is done using this kind of a syntax. You would see this in Gradle, if you're using Gradle to specify build dependencies and task. So this is something that's widely used in a number of places. Because you are running things in a context, it leads you to a very lightweight syntax. So you're going to see this in configuration files. So you can start using this very liberally in your applications. And it's pretty wonderful once you get a hang of how this is working. You can start building your own APIs that are fairly lightweight. But there is still one small problem here. The problem is we set the delegate, but where did we set the delegate though? We set the delegate here on line number 9. But what did we set the delegate to? We set it on the block. What is that block? The block is the input given to us. So you have this function, and the function was given the block, and it took this block and said, hey block, here. And you stick a delegate on it. You probably heard a ouch. And the block said, ouch. You injected a delegate into me, right? It says. What is wrong with that? I don't handle concurrency very well. Who wants to say that? Go ahead. Yeah. Well, but before, you're right. But before we do that, changing an input in any function is morally wrong. Right? It's morally wrong programming practice to receive a data and change it. In any function, an input should just be that. It is an input. We shouldn't mess with the input. You shouldn't change it. That leads to bugs in code. In fact, that's why in effective Java, we say put final in front of parameters so that you don't go mess with it, right? So you don't want to change the data coming in. And why? Then comes your answer, right? If I take this delegate and I pass it to another function, it comes with already a loaded up delegate, which has been an object created in that other object. At the worst case, you have a problem with garbage collecting this. In the best case, it may mess up with an object with wrong functions. Bad things can happen. You say, okay, I do want to set the delegate, but you're telling me I shouldn't modify the object you gave me. So what could you do without modifying the object that was given? Make a copy. Okay, that seems reasonable. So let's make a copy of it. So in this case, this is bad idea because you're changing the delegate on the input. Instead you say define block clone equals block.clone. So we made a clone of the block. And then you're saying block clone.delegate equals mailer. And then you call the block clone, right? And then make a call on it. Actually, without calling this. So you're calling the block clone. So now what did we do? We are saying create the mailer, create a clone of the block, stick the delegate in it, and make the call. This is much safer. You could be passing this delegate to other functions. It works fine. You could be calling in multiple threads. It doesn't have any problems dealing with it. But now we have another problem. You wrote this code, and you have to kind of intently stare at it for a minute. What are you doing with the clone? Yeah, Scott doesn't like it, right? He's like, no. But there's another problem also. What did we do? We set the delegate on this. But what did we do? How did we do it? We used 3 lines of code for it. And I'm sure people told you, in Groovy, you never write 3 lines of code. Everything works in 1 line, right? And you're like, you're writing 3 lines of code. This is not Groovy. Okay, so what we can do instead of doing that is rather than making these 3 steps, you're saying, hey Groovy, why don't you give me a function already to do this? And it turns out that function is called the width function. So the width function basically says, I'm going to call this block of code with the context of the mailer. So the width function literally does the above 3 lines of code. It makes a copy of the closure, sets itself as a delegate, and then invokes the closure. So the width method does the work, and so rather than writing that lengthy method, you simply say mailer.width, and you specify the block of code, and that simply works. So this is a way that you can implement it, and this again is a very common pattern. You're setting a context, and then you're just asking it to run within this, and that gave you this particular implementation. So this, by the way, is the fluent interface that you were able to create. The next thing I want to talk about is currying. Yummy. What is that? Well, no, that's not my favorite spicy Indian dish that I'm talking about. Currying here is a concept that actually was named after a fine gentleman who did quite a bit of work in lambda calculus. He was a professor of mathematics, and he did some really good work. And after he passed away, there were people who said, you know what, hey, these are really nice work he did. And they liked him so much that they took his first name and gave it to a language. And they took his last name and gave it to a concept. What a great way to, celebrate a life, isn't it? And his first name, of course, is Haskell. And there's a language called Haskell that was given from his first name. And of course, the word curry comes from his last name. His name is Haskell Curry. So Haskell Curry basically contributed a lot of things to lambda calculus, and so his name kind of evolved into a language and the concept of currying. But what is currying? Well, in lambda calculus, by the way, when you do prove correctness of things, it becomes really hard to prove correctness of things when you have too many variables coming in. Imagine for a minute there's a function which has 2 variables coming in. When a function has 2 variables coming in, to prove its correctness, you got to decide the value of the 2 variables back and forth. That's a lot of work. What if this function only gets 1 value? Well, that's a bit easier. So if you hard code a value for one of the values, then we can prove the correctness with just the other one, and then maybe we can reason it separately with the other variable coming in. So in other words, it's a nice way to convert a function with multiple parameters into a function with 1 parameter. Now, here is another way to think about it. Imagine for a minute that I have a function which logs a certain content. So if I have a function called log, and I have a level for the log, and maybe a message for the log. So that's my log function. I'm going to write this as a closure in this, please say, starting, right? So I could write it like this. And I could also call this a few more times, right? I could say running, for example. And then I could also say stopping, right? So I could be calling this in these 3 manner. But you look at this quickly and say, boy, this is noisy, right? Because I can reduce the noise just a little bit, but not a whole lot given this. I could say I don't need to put this parentheses maybe, yeah. I could remove this little parentheses in the end, yeah, I could do that. But still, this is noisy. It takes away cycles from you when you look at it, right? Wouldn't it be nice if we can just say, hey, run this in warning all the time. Why am I repeatedly saying this for you? Well, that's easy to do. Let's see how we could do this. I'm going to create yet another closure. This is called log with warning. And the log with warning, or we could say log warning, equals, I'm going to say log.curry, right? So I'm going to do a little bit of work here, and the curry is going to take warning over here as a parameter, right? First parameter. So now rather than calling these three methods over here, I'm going to change this, by the way, and I'm going to remove this part to warning right there, right? So rather than using the log method we used a minute ago, now we use the log warning. Now what does this do though? The log itself takes two parameters, right? So a log function says, give me two parameters. These are the two parameters you need to give for me to come into the log method. We're creating another closure. This closure says, I'm going to cache the warning name. And I'll keep feeding into this guy whenever you call me. But this closure says I only take one parameter. And that parameter is the message itself. And you don't have to give me this other parameter. So in other words, we took up a closure which takes two parameters and converted it into a closure that takes only one parameter. That's what we did here, right? So this minimizes the number of moving parts we have to deal with. It makes it a little easier to work with. So this is called curry. You could curry any number of parameters, right? So if you have three parameters, let's say, maybe I have a warning here as a level, but I also have a date. And I could come in here and say, log warn today, maybe warn today. And I could say today over here, and this could be the date object, new date. Now I can simply come back here and say warn today, log warn today, right? And I could just write it like this. And this could be the log warn today. Maybe this will print the date as well and the message. That's perfectly fine. And you can see that it's doing that. So we curried two parameters. But notice a small detail here. You are currying only the leading parameters. Of course, you could curry all the three parameters. Then you will just call it with no parameters at all, right? You could do that. But you're only currying the leading parameters. If you stop right here, life is simple. But one thing that we never do is, when something becomes complex, we simplify it. The minute it's simple, we complicate it, right? Because we can never leave things simple. This is just human nature, right? This happens over and over and over. So they said, now that this currying works, what if you want to curry the parameters from the right side? What if I want to curry the message and you want to pass the level and the date? And that is called R curry. R curry is currying from the right side. And another name for R curry is bad idea. I don't like it. Because it gets confusing now. Because then you start currying. Now if I want to curry two right parameters, I'm going to give you two right parameters. Now I have a question. I got given you two parameters now. She's nodding already, right? She got it. Is it the date and the message in that order? Or is it message and the date in this order? It doesn't matter which way you go, you're going to be wrong 50% of the time probably, right? And it turns out they actually go from the date and then right, in the same order in which you write. But to me, that's not intuitive. So I recommend you do that if you really hate the people you work with, because they will never be able to understand what your code is doing, right? So use those kind of concepts sparingly. I'm not a big fan of these kinds of code where you have to stop and start staring at it. But if that is not worse enough, there is another thing called N-curry. You can kind of see what N-curry is going to do. Yeah, you can take something right in the middle and say, curry those guys, right? So I would strongly recommend not doing it because it really becomes hard to understand the code. So stop with the currying, right? So in another way, it's a way to think about it is, curry is really tasty, but then you say more spice, more spice. At some point it becomes so hard to eat that you're not going to eat anymore, right? This is kind of the concept where it gets overboard. So don't make it too spicy, right? So don't go currying overboard. Keep it at the right spice level. Excellent. So we talked about currying. Now we talked about this little feature that we saw, which is to really package this method into a closure, or we can use that into a nice feature called the execute around method pattern. This is one of my favorite patterns from the small talk days, by the way. What this pattern says is that when you're performing some operation, you can perform some operations around a certain objects. For example, what is the thing that you do when you use a file? Well, you typically create a file. And after you create a file, what do? You write content into the file. But then to your surprise, the content you wrote quite didn't get written to the file. You kind of wonder, why didn't it write it? Because you forgot to close the file. How annoying it is, right? You write to a file and you forgot to close it, it doesn't write it. And then you say, okay, fine, I'm going to come back and put a close method. And then you kind of mumble while you're writing it. Why can't you be smart enough to close yourselves automatically when I leave, right? Well, rather than creating a file and writing to it and closing it separately, what if we write this a little differently? What if we say, rather than saying something like file equals new file data, stuff dot dat, and then say file dot write something, and then file dot write something else, right? Like this. And then calling file dot close, right? Rather than doing this, what if we were to say file dot open stuff dot dat? And then we are given a file on our hand. And you say file dot write, and you write something in here, right? And then you say file dot write, and then you write something else. Then when you leave the block of code on line number 9, it can take care of the close operation for you automatically. Wouldn't that be nice? This, by the way, is called the execute around method pattern. And this is already implemented in Groovy, by the way. Groovy took the file class from Java and added, methods on it. You would say file, run to close and things like that. Whatever the method name is, you can call that. So essentially this says, I'm going to run in this context, and when I leave the context, I'm going to close it. I've used this, by the way, in a number of cases where you are looking at programmers doing repeated set of code, which gets very tiring. For example, I was working on a project where we would open a transaction first, and then we would run code that is supposed to run within the context of the transaction. And then in the end, we would say, was there any error? If there was an error, roll back a transaction. If there was no error, commit the transaction. Within a week, we saw this code being copied and pasted in several places. Programmers come in and they copy this code, paste it, and change the middle of it. Have you ever seen that happen? There's a name for it. It's called template-driven development, right? You kind of take this template and copy and paste it. In fact, it's even worse. Somebody left a bad comment and they copied with it. I mean, what if it is useful, right? And the same wrong comment is in every way, right? That happens too. When I saw this, I said, wait a minute, we're writing this boilerplate code in every function. This is tiring. I don't want to maintain this code. So what we did was we quickly wrote a little class called transaction and a method called run in transaction. And all that you do in your code is you say transaction.run in transaction, a curly bracket, a closure, and then now you have the code sitting in there. And when you're done with it, you just close it. You cannot forget to close it because the code will complain if you forget to close it. So now you don't have to write that code to say, did this transaction succeed or fail? When you finish the closure, when you close it, the closure goes back to the run in transaction method. And in that method, we come out of the closure. And then we say, was there an error, by the way? If there was an error, roll back the transaction, do some logging, and propagate the error message. Or if there was no error, commit the transaction, life is good, move on. So this is a very compelling pattern, and you can see this happen in several places. This pattern actually comes from the small talk days. And it's a very powerful pattern. And you can use this in almost any language that has lambda expressions. You can use this in Java, when Java 8 ships. You can do this in JavaScript. You can do this in Groovy. You can do this in Scala. You can do this in Clojure. So this is a very common pattern where lambda expressions can be passed in. You can wrap your code. It's called execute around method because you are writing some code, but around that code, there's a pre-operation and there was a post-operation, right? Around your code, there's a preparation and a cleanup. So that is basically given to you. And this is very easy to write. How would you write this? If I were to write this as an example, I would simply write the open method, static open, takes a block of code. And in this particular case, it will create the file. So you are saying whatever the name is, right? File name, comma block, right? So in this case, you would say file equals, new file, something like this, file name. And then you would call the block width. So you'll say file.width block. And then here you would say file.close, but it's even better. You will wrap this with a try and finally block, right? Because there could be an exception in between, and you want to make sure you clean it up properly. So you'll say finally, and you would do the proper cleanup here, right? So in this case, you would do the file close, and in something like this would be what you would write. And so this kind of nicely wraps it. And look at the beauty of this. If you were not thinking about this much, you may not remember to put the try and finally block. And if there was an exception, your file is not closed. But now that you are putting a nice structure around this, it's time for you to think. But once you think and implement it correctly, this gets used and reused everywhere in the code without programmers making mistake wherever they need to use it. So this is a very interesting pattern that comes from the Smalltalk days that can help us to write more effective code. And we can use this, like I said, in Java as much as Groovy when you want to go towards this particular thing. There are a lot more you can do with closures. I'm trying to not duplicate what I said in my previous session. I was doing quite a number of things with, so in fact I would say I was doing this almost all day today, because in my multi-threading talk earlier today, where I was talking about concurrency, I was using a lot of stuff on the closures. And I was then giving a talk on, right before this session, I was talking about memoization. And Groovy has added memoization functions to closures also. And I showed how to do that in that section. And so you could do that also, right? So there are more things you can do with closures and see how you could do concurrency with closures, because there's async method on the closures. There are methods added for really calling concurrent code. You could call trampoline on it, and then you can use tail call optimization with it. That's been done already. There's memoization method to do very effective dynamic programming concepts. So closures in Groovy has turned into one of the most powerful features, and yet it quietly sits around and serves you. With Groovy metaprogramming, we got so many things being injected into closures. The downside is you kind of have to know what's available on a closure and what's not available, right? Because there's no API that says this is all what I can do. But it is very powerful. It's got so many things it can do. And that is the real power of this. So it's a lot of fun to use closures. It's one of the concepts I like. And like I showed you, there are certain things that Groovy closures does that other languages don't do. Like, for example, delegates. Java closure doesn't do delegates. Scala closure doesn't do delegates. So this is fairly specific to the language itself. So I hope you will have fun using closures. And with that, I'll close my talk. Thanks.